I am Priyadharshini from the Department of Artificial Intelligence and Data Science. I welcome you all to the course Computer Vision. Today, let us see the introduction, the objectives and outcomes of this course. Computer vision is one of the most interesting areas in artificial intelligence. It helps the computer to see, understand, and analyze the images and videos, just like a human brain. Today, we are using computer vision on a daily basis. But how does a computer analyze and see an image just like a human? Computer cannot see the image like human. It can only see the images through pixels. Pixels are nothing but a collection of tiny dots. Okay, now let's move on to the objectives. The objectives learn the fundamental concepts related to the image formation and processing. This is nothing but suppose if we take an image or a photo and in night, the image will not be clearly visible. So what we have to do is we have to enhance the brightness and reduce the noise. So our objective is to study about this. Next, learn the feature detection, matching and detection. This is nothing but when we unlock a phone by using a face recognition. So what happens inside it? Already our image is stored. It detects whether the eye, ears, nose, everything matches with the already stored image. And if it is correct, it will be open. Next, become familiar with the feature-based alignment and motion estimation. For example, a CCTV detects the picture of a person who is moving. So, this is used in motion estimation. Next, develop skill on 3D reconstruction. This is nothing but if we are taking the images of a building in different angles and we combine them to make a 3D images. Next, learn image-based rendering and recognition. This we are using in daily basis. For example, Google Lens. What it does, it translates the text to images. So this kind of learning is done here. These are major objectives. And next, the outcomes. So explain the theories and methods in image processing and computer vision. In computer vision, if you have a problem, you will be able to encounter what kind of problem it is and what kind of processing we have to use to encounter the certain problem. There are many type of methods. You will be able to know which method, which problem we have to use. Next, implement the same advanced image processing techniques. For example, in MRI and in CT scans, there will be certain problems which is a minor problem that can be also detected here. Then applying the 2D feature-based image alignment, segmentation and motion estimation. For example, in a mobile phone we are using panorama mode. By using multiple images that we will be learning and the outcome you are able to build it. Next, apply 3D image reconstruction technique. As I said earlier, combination of different images and make them into a 3D image. Next, design and develop innovation image processing and computer vision application. You will be able to do a real-time image, real-time project. For example, a number plate detection or a face detection. You will be able to do a real-time project. Now, let's move forward to explore the computer vision step by step in the following classes. So today we will see about the basic workflow of the computer vision. Okay. What is the first image acquisition? What is it? We just capture the image. Next, pre-processing. In the pre-processing, we use filters to reduce noise. Next, feature extraction. The features are extracted to certain patterns. And then recognition. We identify the particular pattern and segment it. Next, decision making. Automatically, decision is made. The applications of this are healthcare, security, robotics, and autonomous vehicle agriculture. In healthcare, for medical image segmentation, and in security, we are using for surveillance, CCTV camera, as I said earlier. In robotics, we are using for navigations, and in autonomous vehicle, the pathing and also the tracking of the number plates, and agriculture for crop monitoring. Actually, this is a human vision. We see an image, we understand the image, our brain automatically tells what the image is. But the computer cannot identify the image on its own. So what it does, for this image, we have a man, a car, and a dog. So a human brain can automatically identify it as a human, a car, and a dog. But a computer cannot identify it. So what we have to do is we have to train the computer, saying that human by given different data sets and car and for dog. For example, an image of an human first of all is given. Next, what happens is pre-processing. There will be certain noise that will be filtered, and the feature is extracted. For example, here in this image, there is trees, there is dog, there is car, there is a human. So what it will do, according to the pattern which I have trained earlier, the features are extracted, and then it recognizes this is a person which I want, and finally it makes a decision that he is a human being. So why do we need a computer vision, and why do we want to basically study about it? First, we need because it automatically inspects. Next, it reduces the errors. Third, it is a robotic encoder, and the performance will be the best. And streamlined innovation and data charts solutions. So this is the major impact of computer vision. So we'll be learning about everything about in the following classes. So thank you one and all. Meet you again.